Hi, everyone. I'm Anastasia, joined by Irene for day 3 of our 50-day software architecture class. In day 2, we dove into key principles like modularity, separation of concerns, and the SOLID acronym. Today, we're moving forward with an overview of architectural styles, specifically comparing monolithic and layered architectures. We'll break down their pros, cons, and when to use each in real-world scenarios.
Building on those principles, Anastasia, this comparison will show how they apply in practice.
Here's a quick overview of day 3. Architectural styles act as high-level blueprints for how you organize your system's components. We'll zero in on monolithic, where everything is in a single unit, versus layered, which divides into tiers. We'll cover use cases, real examples, and factors to consider when choosing. As usual, share your own experiences in the comments for discussion.
Yes, your input makes this more relatable. Let's get started.
Why bother studying these styles? They guide you in selecting the right approach based on your project's size, team, and requirements. This ties back to day 1's emphasis on scalable systems and day 2's principles like modularity. Choosing wisely avoids costly rework later. Plus, it sets the stage for more advanced styles like microservices on day 7.
Essential for informed decisions, prevents future headaches.
Let's define monolithic architecture first. It's where all components, UI, business logic, and data access, are bundled into one code base and deployed as a single unit. This creates a simple, unified structure that's straightforward to develop at the start. Think of traditional web apps like early e-commerce platforms where everything runs together.
Classic and straightforward. Great for beginners.
The pros of monolithic include its simplicity. Development, testing, and deployment are all in one place, making it faster to get started. Performance is strong since everything communicates directly without network calls. You have a unified code base for easy versioning and debugging. It's especially cost-effective for small teams or projects.
Ideal when speed to market matters most.
On the flip side, cons include scalability limits. You can't easily scale individual parts without scaling the whole app. Maintenance becomes tough as the code base balloons and gets complex. Tight coupling means a change in one area can ripple through everything. Plus, you're often locked into one tech stack, making updates tricky.
Grows unwieldy for large systems, hence alternatives.
Monolithic shines in use cases like small to medium projects, such as startups building an MVP. It's great for teams with limited resources since deployment is straightforward. Think of low complexity apps like internal company tools. It's perfect when you need rapid prototyping without overcomplicating things.
Quick and dirty in the best way for early stages.
Real world examples include early Netflix, which began as a monolith before scaling to microservices. WordPress's core is monolithic, extended via plugins. Basic e commerce sites like simple Shopify implementations often use this. The lesson: start with monolithic for simplicity, then evolve as your needs grow.
Proves it's a solid starting point.
Best practices for monolithic include applying day 2's solid principles and modularity, even within the single unit. Leverage version control and CI/CD pipelines for smooth deployments. Always monitor for code-based growth and plan for refactoring. Organize code with internal layers to maintain some separation.
Keeps it manageable longer.
Common pitfalls. Ignoring modularity from day 2 can turn it into spaghetti code. Don't scale prematurely. That adds unneeded complexity. Poor testing practices mean testing the whole system, slowing things down. As the app grows, it can create team silos and hinder collaboration.
Avoidable with foresight. Today, we're diving into monolithic software architecture, a foundational approach. A monolithic app is a single unified unit with tightly coupled components running as one service. Its simplicity eases initial development, deployment, and debugging for smaller projects. However, monoliths become complex to scale and maintain as they grow, slowing development. Understanding these trade-offs is crucial for your project's architecture. Consider your project's size and team to decide if monolithic fits. Shifting to layered architecture. It's where the system is divided into horizontal layers or tiers, each with distinct responsibilities. Typical layers include presentation for UI, business for logic, and data access for storage. This promotes separation of concerns, as we discussed in day 2.
Layers add structure, builds on monolithic simplicity.
Pros include better maintainability. You can update one layer without touching others. Layers promote reusability, like sharing a data access layer across projects. It offers improved scalability by allowing independent scaling of layers. Overall, it provides clear organization that boosts team collaboration.
Structure without full distribution.
Cons. There's overhead from communication between layers, which can introduce latency. It adds more initial complexity compared to a pure monolithic setup. Misuse, like skipping layers for shortcuts, can undermine benefits. It's not always ideal for very large-scale distributed systems.
Balance is key here.
Use cases for layered include enterprise applications, such as banking systems that benefit from clear tiers. It's suited for medium-sized projects that need modularity without full microservices. Great when you anticipate future expansion. Also, for teams where developers focus on specific roles or layers.
Fits growing business as well.
Examples: traditional web apps using ASP.NET with MVC enforce layers. E-commerce like Magento uses a layered structure for flexibility. Even desktop apps often separate UI, business, and data. Lessons learned. It can evolve naturally from a monolithic base as complexity increases.
Practical evolution path.
Comparing the two. Monolithic is simpler and faster to start, while layered offers more organization. For scalability, layered has an edge as projects grow. Maintenance is easier long-term with layered due to isolation. Choose based on project size, team expertise, and specific requirements.
No one-size-fits-all context matters.
Best practices for both. Start simple with monolithic and introduce layers as complexity demands. Always apply Day 2 principles like modularity, SOC, and solid. Document your architectural decisions for the team and test thoroughly at unit and integration levels to catch issues early.
Hybrid approaches often win.
Pitfalls. Overlayering adds unnecessary complexity to small apps. Ignoring evolution means sticking with monolithic past its prime. Poorly defined layer boundaries create leaky abstractions. And without monitoring, you miss performance bottlenecks in either style.
Stay vigilant and adaptable.
Layered software architecture is a fundamental design pattern, organizing code into hierarchical components for better management. This promotes clear separation of concerns, making systems easier to understand, develop, and maintain. Key advantages include maintainability, testability, and flexibility to update technologies within layers without affecting others. However, performance overhead from layer communication can lead to over-engineering for simple applications. Ultimately, understanding these trade-offs is crucial for robust, efficient software systems tailored to project needs.
Recapping Day 3, we defined monolithic as a single unit style and layered as tiered organization, comparing their structures.
We explored pros, cons, and use cases, showing how Day 2 principles like solid apply. The key takeaway: select your style based on project size, team, and growth needs for optimal results.
Homework. Think about a project you've worked on. Is it monolithic or layered, and why? Questions? Leave them in comments. We'll reply. Thanks for watching. Like, share, and subscribe to continue the journey.
Day 4 dives into creational design patterns like singleton and factory, with code examples.